Hi, in this short lecture, I will talk about merge sort. This is a optional. I just want to show you some better algorithm and merge sort using what we call divide and conquer strategy. You have seen the divide and conquer strategy in binary search. So merge sort also use divide and conquer. Um, you also use recursive algorithm. It continuously split a list in half. If the list is empty or has one element, then it is sorted by definition, because you know a one item in the list, that list is sorted. And once two halves are sorted, then the fundamental operation called merge is performed. The merging process taking the two smaller sorted lists, combine them to make into single sorted new list. So we use recursively split the list into half and half and half until you get to one item. And then we merge them back. Because the list is solid, when we merge, it's much easier to merge. So let's look at the pictorially what it look like. If I take again the same list, I split that in half, because this is an odd number. One list has a 4, one list has a 5. And each of the sublists keeps splitting. So you see it down to one element here, and it down to one element over here, and over here. That means this unshaded element on the bottom, these are the solid list, individual list. It's only one element, but each element is solid. And now we're taking this as a merging process. We're merging, in this case, two at a time. We're merging these two. We're merging these two, these two, these two. When these two merge, the result is merge of 44 because of an odd number here, and so forth. And because we know how to merge these, like 54, 26, we have merging with the order, sorted order, 93, 73. We add when we merge them in the sorted order. Because these two sublists in the sorted order, when we merge them again, it's very easy to merge them. It's only linearly to merge them, like a one pass you can merge them all. And in other words, now we're building up the list from the individual element we build up, and finally the list is merged to the sorted list. Here is a code. I add a print statement to show the splitting of the list, and then I add a code to show the merging at the end. So when I run this, you also see the code is a lot bigger than what you see with the bubble sort, selection sort, or insertion sort. So when I run this, and I will just run this, not debugging this, you will see it was splitting this array or list. In this case, this one do the lower half, and this part is the upper half. You see splitting, merging. Now I merge to this part, and then I do the second half, the upper half, I split and merge, and then at the end I merge, and get the final answer, the final result. The number, this is all the operation you see here. These are all of the operations you see. The splitting and merging, the total number. And what is the total number of splitting and merging? Well, the total number is, if you recall, I said the best, the best for sorting is O n log n. The log n happen because we are splitting the list until we have only one item. The divide and conquer. The n happen because we're merging them, and the product of the two become n log n. All right. This part here had the n effect, and this part here had the n log n. This one have a log n effect, and combine both of them, you have the n log n effect. And we will see the performance of the merge sort when I compare them in the next lecture.